Namaste. Good day, guys, and welcome to the apocalypse. All right, here we are, and in this section, we're going to take a look at section 26.4 of the book, which is the section on how stars group themselves. Okay, so there's a PowerPoint that I didn't make, but it came with the book. I threw it on there, or I'm going to throw it on Classroom, so you could take notes from that also. It also has some really good pictures in it of galaxies and the different types of galaxies that there are. So I want you to take a look at that PowerPoint, but I thought it needed some clarification, so I'm going to try and clarify that PowerPoint with this video. I'm going to try and keep it to about 15 minutes or so. Okay? All right, so here we go. Starting off, all right, the first kind of groups of stars that human beings have noticed are constellations. And in fact, you can see the word stella or stellar in the word. And stellar means star. Okay, constellations are groups of stars that they're not tied together. They just kind of form pictures in the sky, and they just happen to be. They have no real association with each other, stars in a constellation, other than the fact that they happen to be in the same kind of section of the sky as seen from Earth. So, for example, the one that I showed you guys in class or we talked about a little bit, was the constellation Orion. All right, which looks like this, all right, and then it has Orion the Hunter, 3 stars in the center. This is Orion's belt, okay, and then this is the right kneecap, left kneecap. This is the star Betelgeuse, okay, and then there is a group of stars that are kind of like right there, clustered, and they're kind of faint, and this is the scabbard of his sword or something like that. Now, this is a group of stars, but it's not a true group of stars because really these stars don't have anything to do with each other. They're actually oftentimes stars in a constellation, even though they look to us like they're kind of together. They're usually really far apart from each other. So, for example, like it looks kind of, when we look at Orion in the sky, it looks kind of like a flat, like almost like a picture. That's an illusion. The stars are really not like in the same plane. So, for example, Betelgeuse may be like way closer, and then this star over here, the left shoulder, might be like way the heck back here. But to us, looking from Earth, they look like they're together in the same kind of plane, but they're not. All right, like I said, Betelgeuse may be over here, and the other one may be way farther back, and so on. And all these stars are sort of similar in that respect. Okay, another constellation that we see in the sky that is very common is the Big Dipper. And the Big Dipper looks something like this. All right, so you have your dipper. All right. And then you have the handle of the dipper. It goes like that. And so sort of there's your dipper, all right? These two things are these two stars are called the pointer stars, because if you look up and you follow them with your eyes, they'll lead you to a bright star in the sky called Polaris. That's the North Star, okay? And again, the stars in the dipper, although it forms a picture to us and it looks like they're in they're in line with each other, right? Get this in the camera there, okay, good. They're not. They're really not. These stars are really like, one might be way farther back, one closer, and so on. They're really not in the same plane. All right? Okay? Talking about true groups of stars, the first one we want to talk about is a star system. Okay, and the star system consists of like 1 or 2 stars bound together by gravity. So, all right, well, it's 1 or 2 stars. Sometimes, actually, I should say 1 or more. Okay, stars, and they're bound together by gravity. All right, they're bound together by gravity. So, and it also consists of any planets that might be bound together with that single star or couple of stars. Many star systems out there are binary star systems. Okay, so you have, one star and then another star, and they'll be rotating around each other like that. And they may have planets, like this star right here may have a planet that goes around it, and this star may have another planet that goes around it. Okay, as they revolve around each other. Okay, let's see. When you have two together, we say that this is a binary system. You could also have three stars, and that would be called a trinary system. Right? Sometimes what happens is you get oftentimes, well, not oftentimes, but sometimes what happens is you get a very large star in a binary system, and then you have a small dim companion that will look something like that. Okay, and they're revolving around each other. Okay, and the reason why we know that the companion is there, not all the time, but sometimes, depending on how it's rotating, this small little guy will revolve, as it revolves, goes in front of the larger star and actually makes it dimmer. And that's how astronomers know. That's one indication that there's another star there. Okay, is by looking at a star over time, you can see like it periodically gets dimmer, then brighter, then dimmer, then brighter. And when this happens, that's called an eclipsing binary. Listen to the language, eclipsing binary. Okay, we didn't really discover binary star systems until we had telescopes, because oftentimes these stars they're close together relative to each other, but from us, they're so far away that two of them that they look just like one star together. So it wasn't until we had telescopes that we were actually able to see, oh, it's actually two or more stars revolving around each other. Okay. Then the next grouping, the next larger thing. So I want you to think of a star system as kind of like your family or household. Okay. Okay, so that's kind of what a star system is analogous to in human terms. Kind of just like a family, and the kids are they revolve around the parents, whatever. Just kind of go with it. All right, I'm trying to come up with an analogy here. Okay, the next larger grouping would be what's called a cluster. So and a cluster is a larger group of stars that's bound together by gravity. So if a star system is kind of like a family and a household, then a cluster would be like a neighborhood, kind of like wood estates. So wood estates you could look at as like a star is analogous to a star cluster. You have a group of families that are kind of around each other and so on, and they stay together in proximity. There are different types of star clusters. Okay. One is called an open cluster. And open clusters tend to have stars that are, they're bound together by gravity, but they're fairly far apart. They don't have a regular shape to them, that sort of thing. Okay. The second type is called an association. An association, the thing to know about an association cluster is it's temporary. When we talked about star formation, stars come from nebula, and oftentimes in a nebula, you won't just get, when it collapses, one star, you'll get a bunch of stars that form, because remember, nebula are huge, they're very, very large, so you can get many stars that form from a single nebula. And those stars, once they're formed, they're still close together. That's an association. They're not going to stay close together. They're moving. They're moving apart from each other. But right now they're brand new, and so they kind of form. They're still in proximity to each other. Okay, so the sun, for example, used to be part of an association of stars when it was formed, but it's not anymore, because the association that the sun was a part of has long since dispersed into the rest of the galaxy. Okay, So that's the thing to know about these, is that these are temporary. All right. The Pleiades, there's a picture on the PowerPoint of the Pleiades star cluster. That's in Orion, or in the constellation Orion. That is an association cluster. They're brand new stars, and they're not gonna, in a few million years, the Pleiades is not going to be there anymore because they're moving away from each other. All right. And the third kind is called globular. You can see the word glob or globe in there, meaning spherical or circular in there. And these things are very large. They can reach up to like a few million stars. It's still not a galaxy. Galaxies are much larger. Galaxies are billions, again with a B, all right? But these could be 1, 2, 3, million stars or so, and they're kind of bound together by gravity. They tend to be circular, okay, in shape. They tend to be older stars, okay, and they also have a dense center to them. The stars in the center tend to be much closer together than the stars farther out, okay? So that's what constitutes a globular cluster. Now the next level up would be a galaxy. And so let me I lost my eraser, here it is, all right? And I know I keep erasing, but I have to conserve board space, right? Because it's not as big as a chalkboard in the classroom. And the third grouping is a galaxy. And if a star cluster is a family or a household, and then a cluster or a star system is a family or household, and a cluster is a neighborhood, then a galaxy would be the entire, for example, just to use our local area here, would be the entire state of Rhode Island, okay, where you have many more. So state of Rhode Island, you have Providence, which is a big association of people in the center, and then you have your smaller towns, which would be like local clusters of stars, like Warwick and our own town Coventry and Barrington. Those would be clusters of stars, and so on. But the whole state would be like the galaxy. All right, and galaxies are huge. Okay, so they have billions of stars. All right, not just millions, but billions. All right, our own galaxy is called the Milky Way. And that has anywhere from 200 to 400 billion stars. Okay, billion stars in it. Okay, there are different types of galaxies. The kind that we come from is, all right, so the first kind is called a spiral. And again, I want you to make sure you take a look at the PowerPoint so you can see the pictures of this. There we go. All right. All right. And a spiral is, it's kind of what it sounds like. All right. It's a galaxy that has, it looks like a giant, it's shaped kind of like a giant pinwheel. So you have a dense center of stars. See how that shows up. All right. And you have what are called spiral arms that kind of go out from it like that. Okay, and it turns. These are called the arms. This is called the galactic nucleus, with the center. All right, and then you'd have all this, because a galaxy is not just stars, but you also have nebula in a galaxy. Nebula. So a galaxy has billions of stars, but it also has nebula in it, gas, dust, things like that. Okay, it takes the sun, our own sun, it takes 220 million years to go around our galaxy once. So if this was the sun over here, and we, by the way, we're in way out in one of the arms. We're nowhere near the center. And as this thing rotates, and I have the arrow in the wrong direction, it would be rotating like this. As this thing rotates, our sun goes around it, and it takes 220 million years to go around once. That means the last time that the sun was in this position, the last time it was in this position in the galaxy, that means the dinosaurs were just kind of starting up on planet Earth when we were there the last time. Okay? All right. So a spiral, you can get a variation on a spiral called a barred spiral, and that looks kind of like this. So you have your center, and then rather than, you know, kind of like the Milky Way, you get an arm that goes out like this, an arm that goes out like this, okay? And it kind of goes like that as it turns. And that's called a barred spiral. Make sure you know that, all right? The next type of classification of galaxy is called an elliptical. And I didn't want to spell it wrong, elliptical. And ellipticals are oval in shape, okay? They don't have any spiral arms. It's just a different shape. That's all it is, but it's still a very large collection of stars, all right, that looks differently. Again, look at the pictures in the PowerPoint that I'm going, or the Google Slides, whatever that I'm going to send you. And then the last kind is very simply a galaxy that really has no real definite shape at all, and that's called irregular. Okay, so it doesn't have a nice spiral shape, it doesn't have a nice oval shape like an elliptical. It may have some weird shape, okay, like that or something, all right, and all the stars being there, and that's basically it. Okay, so those are your three classifications. Know those, all right. Let me talk about the Milky Way for a second. Why? Because it's our home galaxy. And when we go out into space, it's the first galaxy that we will start to colonize. All the stars that you see in the sky are part of the Milky Way galaxy. All right? Other stars in the universe are parts of other galaxies, but you can't see them. You could see a galaxy far away. The nearest one is Andromeda, but it's so far away that it's very difficult unless you have very, very high power telescopes to see individual stars in those galaxies like Andromeda and other galaxies farther away. So when we go and colonize, we're going to colonize the Milky Way first, all right? So the Milky Way kind of looks like this, right? Well, one, it's 200 to 400 billion stars. I had that up there before. And it looks kind of like this. I showed you how it looks like from above. It looks like a spiral. When you look at it end on like this, it kind of goes like this. Okay, so this would be like looking at the galaxy sideways, all right? We would be out in one of the arms over here, so these would be the arms, okay? This part right here, all right, where it bulges out is called the galactic bulge. Okay, so, all right, and then, so here's an arm, and then this is the galactic bulge, right? And then this right here in the center is called the nucleus, all right? And I'm just going to say it, I'm not going to write it on chalkboard, just that's what it is, all right? Okay. Oh, yeah, I also want you to know that just the relative size of the Milky Way galaxy, it's about 100,000 light years from end to end. So here we are like one end. A star that's over here, when we look at it through a telescope like that, it takes the light 100,000 years to get to us. So if you're looking at a star over here at one of the other end of the galaxy, all right, the light, you're seeing it, when you see it today, the light left that star 100,000 years ago when we were Cro-Magnon, all right? There were no cities on Earth at that time, no civilization, nothing like that. We were living in caves, hunting, gathering, stuff like that. Anyway, so now that distance I want you to know, though, is actually pretty small in comparison with the rest of space. For example, even though this is 100,000 light years, and I'll put a Y there for years, the nearest galaxy, Andromeda, is 2 million light years away. Okay, so it's much, and that's the nearest galaxy. All right, so it's much farther. Okay. The last thing I want you to know are these other objects out there that are neither stars nor galaxies. Well, sort of. All right. Let me show you. All right. And these things are called quasars, and we don't know a lot about them. So let me write it. And quasar it's a combination of two words. It comes from the term quasi-stellar. Quasi meaning not quite something, so quasi. All right, so quasi. Okay, again, quasi meaning like, but not quite. This, for example, to use the word, this is a quasi-class. It's not a real class. We're not in our classroom. We're not together. It's kind of virtual, but it's like a class. So there you go. All right. And what a quasar is, we're not really sure. One, these things, the thing you need to know about them, for the most part, they're very far away, farther than most galaxies. And two, they're very bright. They give off just tons and tons of light. They outshine, one quasar could be as bright as literally hundreds of galaxies with their billions of stars all put together. And what are these things? Not really sure. We think they may be huge, massive black holes that are sucking in stars around them, okay? And as they suck in and they destroy these stars, the matter from the stars accelerates, and when charged particles like electrons, protons, they go faster, they glow, they give off light. That actually is what happens inside like the fluorescent light tubes like that, not the LED lights, but the fluorescent bulbs. Like the curlicue ones that you might still have, or the light tubes that are up at the ceiling of our classroom. All right, the gas inside them, the electricity makes it go back and forth really fast, and when it does that, these things give off light. So we're thinking that a quasar may be like a massive, massive black hole that has billions of stars around it, and it keeps sucking them in, and as they keep going in, they glow even brighter and shine. Okay. So anyway, there you have it. All right, that's 26. Those are notes on 26.4. Okay, again, I expect that you watch this video and that you take a look at the PowerPoint that I'm going to throw up there, and make sure you take a look at the pictures, and then do a Quizlet, take notes on it, stuff like that. Okay? All right, from the zombie apocalypse. Goal is out.